Hi there, this is Penelope. This is a video for science, the level 4 science program at Welltech, and it's a video called What is a Vector? And it's topic 4. In engineering, frequent reference is made to physical quantities such as force or speed or time. For example, we talk of the speed of a car and we talk of the force in a compressed spring. But it's useful to separate these physical quantities into two types. The first type is known as a scalar. Now, they can be fully described by a single number, known as the magnitude. An example of a scalar is, say, the mass of an object. So we might state the mass of the stone is 3 kilograms. And it's really important there to give the units. Quantities of the second type are those that require specification of a direction, as well as the magnitude, before we can say that they're fully described. And this is what we mean by a vector. Now, an example of a vector quantity is a force applied to an object to make it move. Look at this diagram here. If we apply a force in a different direction, it has a different result. So if we apply a force of 5 newtons upwards, it's very different from applying a 5 Newton force horizontally. Specifically, we need to talk about the direction. And if we're talking about force, really important that we talk about the direction. Special methods have long since been developed for handling vectors and calculations, and there are special rules that we're going to look at here. So, just a definition, and we'll put it in a red box in a minute, that a vector are quantities that are specified by giving both their magnitude and direction. And there are special rules, and we will look at these rules both in this video and in the next one. We have to be very careful that we use the words correctly. We can say the speed of a car is 80 kilometers per hour, but when we talk about the velocity, we need to specify a direction. For example, we need to say the velocity of an airplane is, 200 meters per second due north. And we shouldn't use these words interchangeably. We shouldn't use mass and weight interchangeably. Mass is a scalar and weight is a vector with a downward direction. Displacement and distance are related qualities. Distance is a scalar, but displacement has a direction. So displacement has a direction. In this case, we're talking about displacement from A to B, and its distance is simply the 10 meters. Now, a vector can be represented by drawing a line marked with an arrow, and the length of the line represents the magnitude. So the length, this is what we're talking about, is the magnitude of the vector, and the direction of the line is the direction of the vector. Vectors can be written in lots of ways. There's another way that I tend to write them with a little squiggle underneath like that. But all of them start with a line, and a line that has a beginning or a tail and an end, which is a head, and it doesn't matter which way you write it. But the length is the magnitude, and the direction is the direction given from A to B. In this diagram, what we've got is an object that's being pulled by a force of 5 newtons at an angle of 60 degrees to the horizontal. So that angle in there is 60 degrees. So the question is, how do we show this as a vector? Basically, we remove the object and the horizon. So we take those out, and now we have the force represented as a vector. So before we had the little object there and we had the horizon put in, but now taking those away, we've just got a vector. In this case, we could talk about the magnitude. Remember, that's the length. And we'd write it, if our vector was from A to B, we'd write it like that. Or in this case, it might be the vector called F. We also talk about this as the modulus, and we could write that as also maybe that, where that's bold, or that with a little squiggle underneath, or that. So these are all ways we can write the length of the vector. What you need to know about vectors is that we can consider them equal even when their locations are different. In this case, the lengths are the same and their directions are the same. So if we were to put in the horizontal there, that angle is the same as that angle, and their lengths are the same. So we would say that those two vectors are equal. Now here, what I've got here is a diagram of something that's subject to two forces. It's showing that there's a force of 3 newtons downwards and 8 newtons horizontally. And we would need to see, the net result. But at the moment, it's good enough to think of this as possibly having 2 forces operating on it. A vector can have an opposite vector. It's the same length, but the opposite direction. So this is what we call an opposite vector. So it's the same length, but it's going the other way. P and Q are equal vectors. Their lengths are the same, and their angle to the horizontal is also the same. Suppose we wanted to add 2 particular vectors. Now, here we've got 2, they're not equal, they're in different directions, their lengths are different. But suppose we wanted to add these 2 together. So this is what we do. We would take A, like that, and we would join B onto the end of it, like that. So that's B, this is A, and the resultant would be the vector that joins them up. I don't know whether it's called C. The next diagram draws that much more beautifully. So we've got the vector A, a vector B. We're going to add them together. So A plus B, and we're going to call the new one C. And it's just a matter of starting B at the end of A and then taking a vector as the resultant from the beginning of A to the end of B to give us C.